Hey, welcome back to episode number 5 on the series of videos about Paul's 355 small block engine. So we've tried to our best. Starting with episode 1, we received the block in the back of the truck from the machine shop, and we've tried to cover as much detail as possible. And at the same time, we're trying to get the engine built. So that's sometimes problematic. And thanks very much to Alec for being so available and accessible to me. We're trying to cover this thing off as much as I can. And you know, I think I mentioned it in the previous part of one of the previous videos. If you're a car guy, building an engine, building your first engine is even more, it's like the birth of your first child, right? So pretty exciting, and all the stuff that leads up to it, the planning and preparation and checks and research and all that stuff you do, buying parts and all that. And when you finally turn the key and fire it up, what a wonderful, satisfying feeling that is. So, and you know, I don't even know how many engines I built, but it's still exciting. I still find every one of them exciting. So, hope you share that with me. And if you're watching this video, you probably are. So in the previous video, we had all the pistons in. So we're going to show you the oil pan assembly, how we gauge where the oil pan goes, and to connect it to the, not the oil pan, but we know where the oil pan goes. We know where the oil pickup goes. We're going to turn the engine over and do that. So you might think it's unusual. We've got a cylinder head on already. This is just temporary. So one of the reasons when Paul brought this engine to me, I took a quick leak down test. And on this bank in particular, we had 40% leak down on number 4 cylinder. We had 20% on number 6 cylinder. Number 8 was pretty good, actually, and number 2 was pretty good, 9 and 10%. So what I've tried to determine, I haven't done anything to the heads. So when you have leak down, typically there's always some leak down past the piston rings on a new assembled engine that's not even, the rings are not broken in. 10 to 15% is a really good number. So when we had 40% on a running engine, what caused that? So there's 3 ways it could be. It could be past the piston rings, or past the piston, something going on in the cylinder, or the intake or exhaust valve. So before I go taking the heads apart, I need to know what's going on with the heads. So by doing a leak down test now, this is just temporary. I put one head on, I snugged it down just with my little impact. It's not even torqued on. There is a gasket in there. I need a gasket to seal it. Not the gasket I'm going to use. There is a gasket in there. So if Alec wants to come in here, we'll show you how we do this. So what I found was, we'll use this cylinder. Number 4 cylinder before had 40% leak down. And so what we're doing with the leak down, this is my Moroso leak down tester. So it's connected to about 100 psi, 80 to 100 psi of air. So we zero this gauge, and then when I connect this, the leak down tester is going to gauge what percent of air is leaking past. And I went and adjusted that wrong. Got to adjust that back. That's better. Okay, let's see what we got. So we had 40% before. So what I'm trying to figure out is how much of that was past the rings and how much was past the valves. So just a little, watch it don't get you again, Al. That's there. What do we got now? 27%. So the next question is, where is it coming from? So once again, it could be the rings, or it could be the valve. So let's go over here and we'll actually spray into the port and see if it's in the rings. You can see the bubbles there. So that's number 4 intake valve. So some of that leakage is going by the intake valve on number 4 cylinder. Let me come around this side, look at the exhaust side. Now I know that I can see the bubbles on both intake and exhaust valve number 4 cylinder, and that's the one that was problematic before. It was actually 40% leak down before. So I'm going to pay attention to those valves when I take the cylinder heads apart. And we'll do the same on the other side and try to see. Now the other numbers that we got were like 15% on the other 2 cylinders, and we didn't see any on the intake and exhaust valves. And 15% for a newly assembled engine where the rings aren't broken in is not a bad number. So we'll go with that, and we'll come back with you with the rest of the assembly. Just a little add-on note, taking the head off, once again, it was only on temporarily. We didn't even have it torqued. I just had to tighten down with this guy, 15 or 20 pounds. So diagnostics is important. So you determine a problem, you take action to fix it. There's always got to be a follow-up to find out whether you did or not, right? So that is the diagnostics. And usually an engine, after it's running on my test stand, you know, the obvious things, you check for leaks and all that kind of stuff. Then we check the valves, probably a number of times, depending on whether it's a roller cam or a flat tapper cam, and whether it's new. In this case, this cam is used. A used flat tapper cam is better than a new one because it's already broken in. No stress there. But you check a number of things. So two of them is a leak down and compression test. Now we can't do a compression test without cranking the engine. When we get it on the test stand, we'll do that. And we will do a final leak down test when we're all done. But as a diagnostic tool, this told me which valves I need to pay attention to, in particular when I take the head apart. And also, in both cases, the numbers greatly improved from when I did it before. So some of it was going past the piston rings before. And for the good cylinders, it's 10 to 15%, and I can assume that, once again, for a new assembly, rings that aren't broken in, that's not a bad number. So I'm going to take this head off, and then I'm going to flip it upside down and show you how we measured for the oil pan and install the balancer and a few other things for you. So when you torque something down, you start at the middle and work out. When you untorque it, you start at the outside and work in, right? So I don't know if that qualifies as a tip of the day or not. So I got to get all these bolts out of here. No sealant on them because they were just temporarily installed, right? So I think I got them all. We'll tell you in a second. Get off. Okay, now since the last clip, I did go ahead with the last clip. We put number 8 piston in, and I showed you all the processes for that. So if you're interested in that part, check out episode 4. This is episode 5. So a couple things just to note before I've got the oil pump installed. A couple things to note. When you look at the main bearing caps, if you're taking an engine apart, in almost all cases, the OEM stamp the caps, main bearing caps, with a stamp. But you better make sure that you know if there is a stamp there. 5 is not a problem. 1, 2, and 3, and 4 are all the same. They look the same. So there's also a little arrow on this side. That arrow always points to the front, okay? And I've actually, because the stamp number is difficult to see, I actually mark 1, 2, 3, 4, 5 on them myself, and that makes it faster to identify. You don't waste any time doing that. So back to the last video. One of the things I will show you, I got to get set up for it, is measuring torque to turn. Okay, so I didn't plan that, but I just thought I should do it. So as you put each piston in, because I wasn't making a video when I was putting the pistons in, after every piston, rotate the engine around at least full cycle then you can make sure if there's any binding or anything. And if you have any binding at the end and you didn't do that, then you got to wonder which one caused the trouble, right? So after each piston, I do that. And then when we're all said and done, we want to check and see how much torque it takes to rotate the engine. So I'm going to set it, usually it's about 30 foot-pounds plus or minus. And if you have low tension rings, a thin ring package, 16/16 rings versus the 5/64 rings are sometimes a little less, because almost all of the drag comes from the piston rings. The bearings, if you got oil between the bearings and the crankshaft, turning that over just takes very little torque at all. So just to make sure we haven't got something gone bad, here's a 30 foot-pound setup on my torque wrench. So if I can turn this over without hearing a click, that's pretty normal. That's pretty typical. Guys that try to get theirs 27 foot-pounds. There, I got a click there. So it's always very close to 30 foot-pounds. If I go really gently, I could probably get it around without that, but that's a good test. And if it takes a lot more than that, then you better just go look and see where the problem is. Either you got a ring screwed up or something going on, because if it's got a lot of friction now, it's going to have more when it starts up. So that's one test to take. The next thing to show you, so this is a one-piece oil pan gasket, and this is actually a used one. This gasket was on the engine when I got it, when I received it. I cleaned it up, and I'm going to actually use it again, and they're beautiful. The only place you need a little bit of goop is right in this corner right here. Here and here, and then the same corners at the back. And those just to make sure it squeezes down good. And typically you don't have to put any goop on them. Goop. I made that mistake already once calling it goop. So typically Ultra Black or Ultra Gray Permatex is what I use where there's oil present, okay? If it's water present, then we use Ultra Blue typically, right? Now it's all this silicone, right? Just with different colors mostly, probably the same thing. But anyway, that's what the marketing guys tell you. So then you got to buy 5 different kinds of it, right, to cover the range. So that's the only place you're going to group it. Now the other thing is, I'm going to show you how we determine where the oil pump pickup is. But I'm going to have to put a stop here, and we'll just continue on in a second because I got to get set up to show you that. Please like and subscribe. Don't forget to do that. We're trying to get this motor together for Paul, and we're trying to keep videos going and to give you as much detail as we can. It's one of the previous videos, episode 4, I guess. I put the last piston in, and I explained how I gained a little over 0.5 of an inch of main bearing oil clearance by using half a set of 1 thou extra clearance bearings and use the standard bearings. So there's the numbers. These are just King bearings. They're fine. They're not race bearings. They're for street cars, street engines. So 557 SI is for the extended. The X is for extra clearance, by the way. 557 SI is the standard bearing that we use. So I bought a set of these, so I only used a half a set, so I got another set of half a thou oversized bearings, so for another engine. So that's one way of doing that. The other way is grind your crankshaft if you're not happy with the clearance that you have. I talked about that. So when I put the piston in, I used a ring compressor that was a custom-made 4030 ring compressor, and I have quite a few, but I don't have them all. So here is the alternative if you have to put a piston in and you don't have the custom one. This is a stainless steel, expandable, adjustable one, and I have used this on a lot of engines with real good luck. And some of them, the old style, the old barrel style, I've never liked using them. This one works pretty good, and I've used it on, once again, I can't afford to have every size that I've ever worked on anyway. I have a lot of sizes, standard sizes, but I don't have them all. And so for any engine that I don't, So it's adjustable. You get the piston in there, you tighten down on the rings, and you hammer it home the same way I showed with the other one. So someone's wondering, that's one I would recommend. So the next thing is the oil pan. So one of the things you'll note, the gasket. These gaskets are not inexpensive, but they're well worth whatever they cost. This gasket is not even brand new. This is the gasket that was on the engine when I took it apart. I cleaned it up and I'm going to use it again. So that's money well spent. So the next thing is getting the oil pump pickup in the right place. So as I mentioned in the previous video, this is the oil pump that came on it. It was a high volume, these are all milling pumps, 77 HP, high volume pump, and it would have been okay. If you listened to me before, I don't believe in high volume pumps on normal situation. There may be I'm sure there is a place for them, maybe in a big race engine or something that has a lot of loose clearances and needs a lot of oil flow. But typically you don't need one. So I replaced it with a standard M55 milling oil pump. Do I modify them? No, they work pretty good the way they come. And you know, that's kind of one of my themes. If you're going to try and outsmart the factory guys, there are modifications you can make that will definitely not hurt anything, probably make, you know, incremental improvements. But for a standard street engine, I don't modify them. It comes without the pickup, so you got to install the pickup. I have done that off camera. I actually have a little jig. It's not an easy job, or it's a tricky job. Not tricky job, but it's an awkward job because it's hard to hold the pump. But one of the things is I got this pickup where it belongs, and I'm going to show you that. I don't weld it. That's a cast iron piece. I don't like welding steel to cast iron anyways. I've seen some fail. There are other ways to retain it, but this is the way they came from the factory. This pickup was pressed in to the pump, and there's, what did I say last time? It's over 300 million small block Chevs around. 299 million and change are set up this way, and they're doing just fine. The other thing you have to recognize, when you get done setting it up, the bottom of this pickup is about 1/4 of an inch from the bottom of your pan. Where's it going to go, right? It's certainly not going to come all the way out, that's for sure. So I'm comfortable with that. It took a lot of force to press it on, and I'm happy about that. Now, I'm sure we're going to get comments saying you should have welded it. That's okay, you can weld it, and lots of guys do weld it, and it works fine. This one was welded, actually. So you can see what that looks like. Actually, that weld doesn't look too bad compared to some of them I've seen. It's tricky to weld cast iron to steel, and once again, that's the way it came apart. It didn't break anyway, it didn't fail, but then you're also heating up that cast iron in your oil pump, and you got a little spring in there that's sensitive. I just don't like to do that. So that's my story. So where does this go? So typically you want about 3/8 of an inch. So if Alec wants to come in here and we'll look, I made a little sketch for you. So I'm going to show you from the top of the oil pan to the bottom is 7.5 inches. So we'll just measure that. That's 7.5 inches right there. Okay. And then I'm going to measure that's the rail where the gasket is, actually where the gasket is, not where the pan is, where the gasket is, because you're going to the gasket. So I'm going to measure this time over here, okay, where the pickup is. And this is the bottom of the pickup, not the screen, okay? So that's 7 inches on that side, and it's about 7 1/8 on that side. And once again, so that was, 7 1/8 is what I showed there. So that gives me 3/8 of an inch of gap. If you go back to my little sketch here, 7.5 to the pan, 7 1/8 to the gasket, to the bottom of the pickup, and that gives me 3/8 of an inch from the bottom of the pan. Now there's other ways to do that. Some guys, which is pretty innovative, take a 3/8 drill and just tape it onto the pickup, put your oil pan on, and the oil pan will push the pickup down until it stops, and that'll be 3/8, right? And you're going to have your number. So you just want enough that it's not dragging on the bottom of the pan, and as you can see, the sump picks up from the bottom, so the oil has to come in that way. that's how all the OEMs are installed, and they work just fine. So that's it. I'm not going to bore you with showing you putting the pan itself on. I will do though is put the balancer back on. So that's another job that has to be done. So this is his balancer. I put a new gasket. I changed the gasket in the timing cover. I didn't do that on the screen, so I got to put a little bit of oil in here. You want to oil the shaft, and you want to oil the seal as well, right? So, and I've cleaned the balancer up previously, so you know it's pretty good. Let me get it started. As far as we need to go. And this is an install tool, so how it works, there's a little bearing in here. So I got to turn it around because that ends for 7/16 for small block Chevs, and that ends 1/2 for big block Chevs or any other engine that's got a 1/2 inch thread in the balancer. So I'm 7/16, so I need to go this way. And I probably got to back this out. So this is one thing I mentioned before with the timing gear. It's pretty common to hammer those on. I put mine on with heat so I can actually push it on with my hand. It's pretty common, but you sure don't want to be hammering this thing on, that's for sure. You want to make sure that you use a proper tool. If you haven't got a tool like this, you can usually borrow one at an auto parts store. So, okay, I think I'm bottomed out pretty good there. And I actually have to get a wrench anyways. First of all, I better make sure that, yeah, now you don't want to have it jammed in there, so I usually back it off a little wee bit to make sure your tool's not jammed in there when you're all said and done. And you use this one to hold it from turning, and this guy to put the balancer on. Now let's put a little more oil. And on it goes. When you get to the end, the balancer will tell you. There we go. And so, balancer's on. I won't bore you watching me bolt the oil pan on. But once I get that oil pan on, by the way, on the oil pan, we took this oil pan apart, and the baffle was a pretty nice looking pan, but the original welds in the baffle were broken. So Performance Unlimited were nice enough to tack weld it for me in multiple places, and they actually painted it for just because they like me or something. I'm not sure really why, but anyways, thank you very much to Barry and his guys for doing that for me. Appreciate that. So put the pan on. Once that's on, I'm going to turn the engine over. It's not going to get turned again once we get it turned over. And we'll be putting the cylinder heads on. There's a process there. We are going to use stainless steel head gaskets, 15,000 stainless steel head gaskets. I am going to paint them with copper, seal the gasket or whatever they call it. Probably don't have to, but I'm going to anyways, and I'll show you that in a future video. Thank you for watching Gold's Garage. That's episode 5 and counting, and we're doing our best to show you as much as we can. Let me know in your comments if there's anything I'm missing or got it wrong or whatever. Happy to read the comments and reply to as many as I can. Thank you for watching Gold's Garage.